large integer operations. So suppose given a number n and you are asked to find out the factorial of a number, generally when you declare a variable as int, we know there is some limit, it has some range. Okay, if the size of integer is 4 bytes, then it can store minus 2 power 31 to 2 power 31 minus 1. Only maximum of this much range can be stored. But if I take a variable as double, still no, we can take around minus 127 to 2 power 127 minus 1. This can be the maximum range which we can store. When I declare a variable as double n, if I declare and I want to find out its factorial, we have a limit in that. So the problem is, when you find out the factorial of 10, that's okay, this double variable will give you. When you find out factorial of 100, it is very large number which is beyond this range. So how do you find out factorial of a large number? Okay, that is problem 1 which we will be seeing today. So is it not possible to calculate? Say mathematically, factorial of any number can be found out. If I give you pen and paper, a big paper and a team of 10 people, if I ask you to find out factorial of 1000, it is possible you can find it out. The only challenge here is, when you are finding factorial of a large number, there is high chances you may make mistakes when you are doing manually, or it is time consuming. It is time consuming. That's why we depend on programming, we depend on writing a program, we take help of a machine to do this job for us. But when you declare a variable as integer, maximum I guess you can find out the factorial of 72, something like this. Beyond that you cannot. So when you give, even if you give double, you cannot find out factorial of something like 200 is not possible, because it has some limit. So how do we find out factorial of a large number? That is first problem, that is large integer operations. And also some operations like addition of two large numbers, subtraction of two large numbers, and multiplication of two large numbers. So all these problems we will be trying to see. Let us understand to find out the factorial of a large number. So when you are finding factorial of a number, generally we know this logic. Using for loop, we write fact equal to 1, and for I equal to 2, I less than or equal to n, I plus plus, fact equal to fact into I. This is normal one which will give us the factorial of a small number, right? But if I want something greater than 20 factorial, its range is more than this. So suppose I want to find out 500 factorial, it is difficult. So what can we do? How can we find out factorial of a large number? For this, we take help of the concept of arrays. What we try to do? We will store the value in an array. We will try to store the value in an array. Okay. So using taking help of an array, we will be trying to find out factorial of any given number. You give any number, we can find out its factorial, irrespective of the data type. Okay. So by storing the result in an array, suppose, see what is the meaning of 2 factorial? Means 2 into 1. What is 4 factorial? 4 into 3 into 2 into 1, right? So what I am trying to do here, when n value is given to us, you multiply n with 3. You store the result in an array. Then that result you multiply with 2. Or indirectly I will say, when you want to find out 4 factorial, store 4 in an array. Let there be 4 here. Multiply this array element with 3. Store that again in the same array in the result. Okay, like this 12 you store it. Again multiply this with 2. Store the result again in the array 24. Again multiply it with 1. Again store the result in the array, that way. So the approach is very simple. Store the number in an array, you multiply with the the remaining numbers. Like if it is 4 means 4 minus 1, 4 minus 2, 4 minus 3 and so on. You multiply and store the result always in an array. Okay. So that is the logic here to find out factorial of a large number. Let us see an example and try to understand. Okay. So assume, let me take one array, F array, you have to take one F array. Okay. So assume you are trying to find out factorial of 11. Okay. You want to find out 12 factorial. You want to find out 12 factorial. So assume the 11 factorial is already found and it is stored in reverse order. Okay, this way I am storing the factorial of 11. Assume, see, directly we are beginning from 11 factorial. To explain you the approach, how it works. Okay, to understand the general procedure, let us see how it works. When you are finding factorial, you have to store the number in reverse order. Any operation you are doing with large integers, it is recommended to store in the array in reverse order. Okay, we will come to know why we are storing in reverse order. Why we have to store in reverse order? See, what is factorial of 3? 3 factorial is 12, 4 factorial means I will have 24, right. Now, when I want to find out 5 factorial, I have to multiply this 4 factorial result with 5. So, which two numbers I am multiplying here? See, 5 into 4, I am doing 5 into 4. So, this is 0, this is 2. Then again 5 into 2, that is 10 plus 2. So, 120, I will get answer like this. So, you are multiplying 5 and 4 first, then 5 and 2. That is why we are storing the elements in an array in reverse order like this, 4, 2 and 5 like this. So, I can multiply A of 0 and B of 0. So, 5, 4, 5, 2, I can keep multiplying it. That is the reason we are storing the result in reverse order. So, the approach here is assume 11 factorial is already found, there exists a array F which already contains the result like this. Let this be the result. See, 11 factorial is 39916,800. I have stored that into reverse order. Now, when I want to find out 12 factorial, already the array contains 11 factorial value. Now, what I have to do? This 11 factorial value into 12 I have to multiply. So, I have to multiply this with 12. So, how do I multiply it here? See, you have to multiply 12 with which number here? With 3. You have to multiply, you have to multiply 12, with f of 0, that is 12, 0, 0, then f of 1, 12, 0, 0, then f of 2, multiply 12 with f of 2, 12, 8 is 96. So, 6 comes here and carry is 9. Okay. So, what I am doing here, f of I into 12 I am multiplying. Okay. That result I am storing here. Okay. So, I am trying to take the, when I multiply 12 into 8, answer is 96. From this you take the remainder, that is 6. 6 you put in the F array and 96 by 10 you do, that gives your carry 9. Okay. So, like this. Next, again we got 96, digit is 6 which I have placed in F here and carry is 9. Then what is the next number? You have to multiply 12 with 6. So, what is 12, 6? 72. 72 plus earlier carry, whatever carry you had, that is 9, right, because previously we have one carry, that is 9. So, that I am adding it here, it becomes 81. From 81 again extract the remainder, that 1 you store it in the array and carry will be your 8, that is 81 by 10, your carry will be 8. Again, what is the next number? 1. So, 12 into 1, it is 12 plus the previous carry 8, if I add, I get 20. In that 20 I will put 0 here and 2 will be my carry. Same way. So, again next multiply 12 into 9, next one is 12 into 9. So, when I do 12 into 9 it is 108 and the previous carry is 2. So, 110. From 110 digit is 0, carry is 11. Digit is 0 I have placed here, carry is 11. Again multiply 12 with again 9. So, it becomes again 108 plus 11 equal to 119. Here again, what is the digit? Digit means that number, that result 119 modulo 10 you do, that remainder you place in the F array and that you divide it and you get the carry. 119 divided by 10 if you do, you will get 11. Let 11 be the carry. And the final value multiply 12 with 3. So, 12 3 is 36 plus the previous carry 11 equal to 47. So, 7 comes here and carry is 4. When the carry is left over, left over, you have to add it at the end. Okay. So, this result, the elements in the array here is nothing but the 12 factorial value. Okay. So, what we are trying to do now, if we generalize the process what we have seen just now, right. So, what we are trying to do here, we are trying to store the number into the array. You are trying to store the number into the array. So, what is our case? See, let us assume I want to find out 4 factorial. So my f array will contain only 1. Let me take 4. It will contain f array will contain 1 here. Now what I have to do? I have to multiply this with 2. I have to multiply this with 2. When I want to multiply this with 2, I will take f of 0 value into 2, I will multiply, store the result back in f. So the result becomes here 2. Again take f of 0 value, multiply with 3, again you put 6 here. That way we have to increment it. So see the approach once again. Assuming that the 11 factorial is already calculated, I will tell you how it comes. We will write the code and implement this. Assuming the 11 factorial is something like this, in reverse order is already placed nicely, and you are supposed to find out 12 factorial. What we are doing? You are multiplying 12 with f of 0, you are multiplying 12 with f of 1, you are multiplying 12 with f of 2, multiplying 12 with f of 3, and so on. When you are multiplying 12 with f of 0, let that be p. So p equal to f of I into that n, that is 12, because I am finding 12 factorial, n is 12 here. Now when you multiply f of I into n, you get p. So f of 0 should be here this p modulo 10. Whatever output you get here, its remainder should be placed in f of 0. Then we have find out carry. What is carry? Carry is nothing but this p by 10. So whatever result we got, that by 10 you do, that is your carry. Okay, so this way we have to multiply. So the first case, what happened here? 12 into 0, 0, and carry is also 0. Then 12 into 0, again 0, carry is 0. 12 into 8, it is 96. So f of 0, what should I place in f of that is I became 2 now, right? So f of 2. F of 2 should be 96 modulo 10, that is 6. So 6 has to be placed here. And then C equal to 96 by 10. So we get 9. That 9 is the carry. So what we are trying to do? We are trying to perform series of operations. We are trying to perform series of multiplication operations with the array elements. Now once you do this process, once the entire number is placed here, right, this you have to print in reverse order. Once you print in reverse order, you get the actual answer, that is 12 factorial. Like this, even if you want to find out 100 factorial, your array size will keep increasing and you will be placing all those values here. You can print it in reverse order. How many numbers are there? Till how long did I go? That count I am maintaining in a variable. If you see here, ND6, ND7, ND8, I am maintaining a variable here, right? What is this number? It's an index. It's a count variable. As and when I am inserting a number into f, I am incrementing the count. Why? This count holds how many digits are there in the f array. Okay, in the final f array, how many digits are there, that we are storing in the count array. Okay, so with this we were able to do the factorial of a large number. In generalized, if you see the process, you have to take an array. Okay, let us see the procedure here. Again, this is very complex to understand. Let me directly go to the program part. Okay, we will try to understand the algorithm and then we will try to implement this coding of this. So I am taking ND. ND is an index. It's an index to maintain how many elements are there in the f array. So f of 0 equal to 1. Why? Factorial of a number begins from 1. No, even if you want to find out 3 factorial, in our approach, what we are trying to do, we are storing 1 in the array, multiplying this with 2, storing that in the array, multiplying this with 3, and so on, right? So that's the reason we are initially putting f of 0 as 1. This is just an algorithm to understand. Carry will be 0. Initially the carry is 0. Now from n equal to 2 to m, where m is the value which I want to find out. M is the value for which I have to find out the factorial. See, 0 to nd minus 1, 0 to nd minus 1, what I am doing? P equal to f of I into the n plus carry. Why n is 2? Because already f of 0 I have kept as 1. Suppose I want to find out 4 factorial. So this n value will range from n equal to 2, n is less than 4. So this way we will iterate it. Okay, n again 4 factorial means equal to 4, n is less than or equal to 4. So, first time I am multiplying, what is there in f of I? F of I contains 1, see f of 0 contains 1, right. So, I is equal to 0 to nd minus 1, p equal to f of I into n. Okay. So, then carry is 0, f of I is 1 into 2, 1 into 2 plus 0. So, p becomes my 2. When p is 0, again in f of 0 in the f array and 0th index I am putting p modulo 10. What is p value? P value is 2. P value is 1 into 2, that is, yeah, it is 1 into 2, that is 2. So, 2 modulo 10 is 2, that you put it here. 2 by 10 carry remains 0, carry remains 0. Again carry not equal, this will come back, again go back to the for loop. This will break, again it will go back on top, n becomes 3 this time, n becomes 3. So, again f of I, what does f of I contains? 2, 2 into 3, 2 into 3 plus carry 0. So, this is 6, again place 6 modulo 10 is 6, 6 by 10 is 0. So, no change, we will get 6 here. So, in place of 0, 6 comes here. Again this nd, no, it will go for second time, because nd we have taken as 1, somewhere we are doing nd plus plus, I will talk about that nd plus plus. Okay. Again go back, n becomes 4, it becomes 4. So, yeah, n value becomes 4 this time. So, f of I into 4, f of I into 4 plus carry which is 0 only. So, what does this becomes? Here f of I, that is 6 into 4 plus 0. So, this is 24. Now, when it is 24, what should be inserted in f of I? What should you put here in f of I? See, f of I equal to p modulo 10, that is 24 modulo 10, you have to place here 4. Again carry equal to p by 10, 24 by 10, that is carry becomes 2. Now, carry not equal to 0, this time it is entering this while loop. While carry not equal to 0, nd plus plus, nd, see, nd was initially 1, now nd became 2. F of, no, here f of nd minus 1, so it was 0, this becomes 2 now, it becomes 1 again. Sorry, nd means it becomes 1. So, in index 1, I am putting carry modulo 10, that is 2 modulo 10. So, I will be putting here 2. Carry equal to carry by 10, that is 2 equal to c equal to 2 by 10, that is 0. So, this way now you see you got 4 and 2, and what is nd value? Nd value is 1. So, it means in f array there are up to index 1 there are elements, print them in reverse, you get answer 24. Okay. So, this is the general procedure. I will explain once again what is the logic of finding factorial of a large number. Let us try to understand this. How do we find out the factorial of a large number? See, I want to find out m value is 5. I want to find out 5 factorial. So, initially take one array, f array. I will tell about its size. For now, you assume some elements here. I will talk about the size. So, indexing 0, 1, 2, 3, 4 and so on. This is f array. Now, let nd is a counter, let it be 1. Then f of 0 equal to 1. So, place 1 here. Carry is equal to 0. So, carry will also be 0. Now, n equal to 2 to m, that is 2 to 5. 2 to 5. Again, for I equal to 0 to nd minus 1. What is nd? 1. 1 minus 1, 0. It means for I 0. For I 0, what will I write here? P equal to f of 0 into n. What is n value now? Here in the iteration, first iteration n value is 2. 2 plus what is carry value? 0. So, this result is f of 0 is 1. 1 into 2 plus 0, that is 2. Now, next step, f of I equal to, what is I value? See, I value is 0. I value is 0. F of 0 equal to p modulo 10. What is p value? 2. 2 modulo 10 is 2. 2 modulo 10 is 2. Therefore, I will be writing here f of 0 equal to 2. Then carry equal to p by 10. P value is 2. 2 by 10 is 0. So, carry remains 0. No change in this. Is the carry not equal to 0? No. Go up here. This loop breaks. Again from here go up. N value becomes 3 this time. N value becomes 3 this time. Okay. Now, again I equal to 0 to nd minus 1. I equal to 0 to nd minus 1 means again 0 to 0 only. again 0 to 0 only. Again p equal to f of I into n. What is n value now? N value changed to 3, no? N value changed to 3. So in this case it becomes f of 0 into 3 plus the previous carry is 0, no change. So what is f of 0 value? 2. 2 into 3 plus 0, this is 6. Now f of I, what is I value? 0 only, because this loop is ranging from 0 to 0 only. So f of 0 equal to p modulo 10, that is 6 modulo 10. 6 modulo 10 means 6, that where I have to put in f of 0. So f of 0 contains 2, this will be erased and 6 comes here. Carry equal to p by 10, that is 6 by 10, again 0, so no change in the carry. So carry is not equal to 0, I will go up, this will fail, again I will go up, I will make n value to 5, sorry, n becomes 4 this times, okay, n becomes 4. Now again, here again I equal to 0 to nd minus 1, nd value is again 1, no change, so it is from 0 to 0 only, it is from 0 to 0 only. Now p equal to f of I into n, so let us again evaluate this. F of I value is 0, so f of 0 into n, what is n value? 4, 4 plus previous carry is still 0 only, 0. So f of 0 contains 6, 6 into 4, 24 plus 0 is 24. Now what should I put in f of I, where I value 0 means f of 0, what should I put? I should put p modulo 10, that is 24 modulo 10, so it is 2. So in place of f of 0, 4, I am sorry, this is 4. In place of f of 0, I have to place here 4. Now next, carry equal to p by 10. What is carry value? 24 by 10 is 2. 24 by 10 is 2. Check here, while carry not equal to 0. Is carry not equal to 0? Yes, it is not equal to 0. Then f of nd plus plus, okay, f of nd plus plus. What is nd value? 1. It means f of 1, I have to put, what I have to put? Carry modulo 10, that is 2 modulo 10. I have to place here 2 and then increase this nd value. Now nd becomes 2 in this case, nd becomes 2 in this case, and carry equal to carry by 10. So 2 by 10, carry becomes 0. So carry becomes 0, right? So I got 24 here. This process is over. When you go back again, it fails. Again go up now. Now n value will change again to, so after multiplying with 4, we got this as the value. Go to third iteration or the final iteration. N value becomes, from 4 it becomes 5 here. Again I equal to 0 to nd minus 1. In this case now what is nd value? 2. 2 means 2 minus 1 means 1. So I have to iterate it 2 times, nd 0 and nd 1. P equal to f of I, that is f of I into n value is 5 plus carry, initially it is 0. So f of I means, f of 0 means 4. 4 into 5 plus 0 is 20. Okay. Now what should I store in f of 0? In f of 0, I should store 20 modulo 10. Remainder is 0. So I will put here 0. I will put here 0. Then carry equal to 20 by 10. What is carry? Carry equal to p by 10. 20 by 10 is 2. So carry not equal to 0. F of nd plus plus. Nd value nd plus plus. So what I have to store here? In this one, it is carry modulo 10, that is it becomes 2, and carry equal to carry by 10. So what was the carry we got earlier here? 2. 2 by 10 is 0. So carry is 0 in this case. Okay. Again go up here. Now I becomes 1. So p equal to f of I into n. F of I into n. That is n value is 5. Okay. So no, this will remain same. We got here initially we had 2. 24, no, 4, 2, yes, we had 4 and 2. So this case it will take this f of I value, that is 2, 2 into 5, 10 plus carry 0, right. So that way if I update, it becomes 10, 10 modulo 10, it is remainder is 0, then we have carry equal to p by 10, so we get 1 here, right. So this way we are trying to store 120 into the array. This is the logic of finding out factorial of a large number. If we summarize again, when you want to find out the factorial of a large number, assume that it is stored, we have to store that, yes, let us see the program, we have to know here, we have to create an array, temporary array with zeros, then iterate from n to the number 2 to the number m for which you want to find out. take the f of 0th element, multiply it with n and add with the carry. Okay. Repeat this procedure to fill the array, and at the end you have to print the array in reverse order. When you print the array in reverse order, you get the actual factorial value. So, this is the C++ program. For doing it, we will try to implement it and see step by step how we are getting the answer. So, this is the logic of finding factorial of a large number.